Okay guys, in this video we are going to take a look at reviewing local maximum, local minima and saddle point for a given function. Alright, so the first thing I would recommend doing is finding all of the derivatives that are here and also inserting them in Desmos. So I have the Desmos calculator here and I'm gonna put f of xy. So that would be x cubed plus xy squared plus 6x squared plus y squared. So that's the original function. Then I'm going to also insert the first derivative. So what would that be? So if you are working on the derivative with respect to x, you're treating y as a number. So x cubed with respect to x becomes 3x squared plus xy squared. So think of y squared as a number, that's y squared. And then plus 12x. Now y squared will go to 0, so that's not going to be there. So I am going to insert that here. Okay, now I do partial derivative with respect to y. Similarly, I'm treating now x as a number, so x cubed is going to go away. I will get 2xy. Then 6x squared becomes 0 plus 2y. So let me enter that over here. Okay, then I'm going to enter all the second partials. So f(x(x) first, which means that you take the partial with respect to x and take another derivative of this with respect to x. So that becomes 6x from the first term. Then y squared will drop out because it doesn't have an x, and then plus 12. Okay, xy will be the derivative of this with respect to y now. So the terms that don't have y will drop out, and so this will just be 2y. And finally, fyy is where you take the y derivative and take that with respect to y. So that should be 2x plus 2. Now, notice also that if I were to take the derivative of this with respect to x, I would actually get 2y, which should coincide with what I got for f of xy, which is, so that means it's good. All right, now there's one other thing that I would need to enter, and that is the d. Okay, so d is that determinant that's going to determine basically whether it's going to be a max or min or a saddle point. And I always recommend typing it. So you have it on the formula sheet. The way it works is you take f(x(x), and notice how you have to put xy everywhere, xy, multiplied by fyy, and subtract fxy, again, xy squared. Okay, so that's your d. Okay, so now that you have all of this, the next step is to solve the gradient equals 0, to solve it for critical points. So I will make each one of these equal 0, and usually try to use some sort of zero factor property unless it's obvious what the solution is, but here it's not that obvious. So I think the second equation, so I got two equations, number 1 and number 2. And whatever pair of numbers x and y, they have to work for both equations. That is key, okay? If you found a critical value, it better satisfy both equations. Okay, so I'm going to use zero factor property on the second term. I can see that 2y I can factor out, so second equation, I will get x plus 1 equals 0. Now, this, according to zero factor property, can only happen if either 2y equals 0, which will give me y equals 0, or x equals -1. Now, one of the common mistakes that I see people do is they think that that means that the critical point is -1, 0. But zero factor property says it's either one is 0 or the other. They do not have to be both zeros. So if you think that -1, 0 is really a critical point, then if you were to plug it into the x fx and you plug it into fy, you would get 0 for both. Yes, you got 0 for the first one, but you didn't get 0 for for the second equation, but not for the first. So this is not correct. So I immediately know that -1, 0 cannot be a critical point. So what am I supposed to do next? Well, what you're supposed to do is look at two cases. So case number 1, let's say x equals -1. Let's go to the first equation and plug in x equals -1. So -1 squared is 1. So I get 3 plus y squared, and then minus 12 equals 0. Now solving that, I get y squared equals -12 plus 3 is -9. When I move it to the other side, that would be +9. And so that means that I get y equals 3, y equals -3. So my points are -1, 3, and -1, -3. Now, how do I know these points are correct? As I find them, I can go ahead and check this out. So see how both fx and fy are 0, so I know that I got it right. Also, -1, -3, also got it right. So I already know this is right. Okay. Now, case 2, that is when you were saying, okay, now y could be 0, right? So that's another possibility. So if y is 0, let's go back again to the first equation, and then we're going to get 3x squared plus 12x equals 0. Now, how can that happen? This is where I use another time zero factor property. So I factor out 3x, I will get x plus 4, right? And again, this separates into either x equals 0 or x equals -4, which means that I also have 0, 0 and -4, 0. Okay, so let's put that and make sure that that's correct. So f of 0, 0, fx of 0, 0 is 0. And same thing with fy. I checked it, I know. Okay, now -4, 0 also works. So I know that these are my critical points. I got 4 of them. And now I'm supposed to classify each one of them according to my rules. Okay. All right. But first, what I will do, so if you want to go ahead and enter that here. So we've got the points. So -4, 0, -1, 3, -1, -3. So it wants you to evaluate the original function. That's fine because I already have it here. So I'll just put that here. And so the original function at every one of these. So let me just start typing them here. Okay, then I got, well, let me just erase this. This is -4, so that's 32. Okay, original function -1, 3, that's 5. And finally, -1, -3, that's also 5. So this tells you that the point in space is that where is either max or min or saddle point is going to be 0, 0, 0, -4, 0, 32, -1, 3, 5, -1, -3, 5. Okay. Next, what I want to do is plug each of these points into fxx. So fxx at 0, 0, okay, that's 12, all right. Then I want to plug -4, okay, -12. Then I plug -1, 3, okay, that's 6. And then -1, -3, that is also 6. Finally, I want to plug everything in D. So D of 0, 0, okay, it got 24 here. D of -1, 3, okay, that's -36, -1, -3, that's also -36. And at -4, 0, I still haven't gotten that, that's 72. Okay, so that tells me that now how am I going to classify them? So in order to classify them, I need to look on the formula sheet. So the formula sheet tells me that if D is positive, no, if D is negative, then that's a saddle point, and I don't need to look at the fxx. But if D is positive, then fxx positive, it's a min, fxx negative, it's a max. So looking at what I got here, for the first point, D is positive and fxx is also positive, that would be a minimum. Here, D is positive, but fxx is negative, that's a maximum. And both of these, it doesn't matter what fxx is, as long as D is negative, that's a saddle point. Okay, now I also wanted to show you, so I'm basically done with this, but I wanted to show you the graph that I created in CalcPlot 3D so you can see. And I also plotted all these points that we got. And so I want you to make sure, like looking at it visually also, does it make sense? So here is point -4, 0, 32. So you can see it right here, that's red point. That is definitely a local maximum, right? Very clear. Okay, then I've got 0, 0, 0. So according to what I said, what was 0, 0, 0? 0, 0, 0 was a minimum. Okay, so where is 0, 0, 0? That is this point, it's purple, so you can see it, right? That's a minimum, that makes sense. This looks a minimum, okay? And then the other ones, -1, -3, 5, and so this one is green. And I'm not sure you can see, oh, okay, you can see that green point right there. That's a saddle point. So what does that mean, a saddle point? So it depends on how you look at it. So if you look at it from this view, it looks like a maximum. But if you would look at it from the other view, and there is probably another view, you can see that it's going to be a minimum. And then on the other side, it's going to be exact same thing. So this other point that's blue, I'm not sure you can see it. There it is right there. But it's also a saddle point. So like on one side, it's a max. On the other side, if you look at it on the other way, that's a min. So that's what special about the saddle points.